Good morning everyone. Today we will be learning about the determination of major losses in pipe flow. So this is the experimental setup. So before going for the conduction of the experiment, we'll go to see the introduction part of the experiment. So what is a pipe flow? A hollow circular cross section and material which is used for the flow of a liquid or a fluid is known as pipe flow. So generally what we are going to assume, the pipes are in circular section and it will be running in full condition. Then when a liquid is flowing through a pipeline, it is always subjected to a resistance force. So depending upon the velocity, this resistance may be divided into two types. That is the first one, viscous resistance, and second one will be a frictional resistance. The viscous resistance is mainly due to the molecular attraction between the molecules of the liquid. When at the lower velocities of flow, so the fluid particles will move in straight lines. So this is known as laminar flow. But at higher velocities, the liquid particles will move in a zigzag way. So that is known as the turbulence. So that is mainly because of the frictional resistance. So the frictional resistance will go to develop the boundary walls of in between the boundary walls of the pipe and the liquid particles. So today, what we're going to do in this session, so we're going to determine the Darcy's friction coefficient for a given pipeline. So let's come to the experimental setup. So what are the operators we need to conduct the experiment? That is the first one. So you can see a pipeline which is fitted with a differential manometer. So there is a pipeline which is fitted with a differential manometer. Then second one, a control valve for regulating the discharge. So that is the control valve for regulating the discharge. Then next one is the measuring tank or a collecting tank which is fitted with the piezometer. So these are the things. Along with this equipmental setup, we need stopwatch to note down the time. So this is about the operators what we need for the conduction of the experiment. The next one is specification part. Specifications are nothing but so what you need to do before going for the conduction, you should note down. So what is the length of the pipeline and what is the diameter of the pipeline. So after that you should note down the measuring tank dimensions. That is the length of the measuring tank and breadth of the measuring tank. So these are the specifications what you need to note down before going for the conduction. Let's we'll begin with the experiment. We'll go to start the experiment. Just come here. So procedure part briefly I'm going to explain. So after that we'll go for the conduction. Procedure, what you need to do, nothing but during the conduction of the experiment you need to follow certain steps. So that is the first step what you need to follow. So first one, switch on the equipment and check the water flow in the pipelines. So the second one, after switch on the equipment, what you need to do, so come here, then check the manometer connection which is properly fitted with the pipeline or not. You should check that one. Then after that, then if any air voids, if it is there in the manometer, that must be removed before going for the conduction. Then after that, what you need to do, so you should open the regulating valve and corresponding ball valves of the pipe. Then come to the nearby the differential manometer. Then record the left and right limbs of the manometer readings in terms of mercury head. Yes, after that, so once after taking the manometer reading here, come here nearby the measuring tank. Yes, here just close this the flow valve in the measuring tank. Then you note down, so what is the rise in water level for a known time. Yes, for example, for a 10 centimeter rise, what is the time taken, or for a 5 centimeter rise, what is the time taken, like that you just note down. So once if it is over, that is for a given pipeline. For example, there is a galvanized iron pipe. For this pipeline, the one trial has been over. We'll go next one, we'll go for the calculation part. So similarly, we have to go for the another pipelines. If it is there, if you need to conduct, we can determine for that pipelines also. So what is the friction factor? So that is the procedure on the steps what you have to follow during the conduction. Now come to the pipelines we're going to see. One is a galvanized iron pipe of 1 inch diameter. This will be PVC pipe, and this will be same galvanized iron pipe of half inch diameter. Now come and just switch on the equipment. Now you can see the discharge valve. It is already open in condition. You have to open that discharge valve. Then come here. Just you have to remove the air valves if it is present in the manometer tube. So yes, you can see that clearly it has been removed. Now you can close this valve. Now for which pipe you are, if you are, suppose example, if you are conducting for the 1 inch galvanized iron pipe, so you can see the manometer tube which is connected to the pipe. Just these pipes, you just open it. Open these pipes. Now what you have to do? Now come and close this from here and open the ball valve of the 1 inch diameter pipe. Yes. Now just close this discharge valve. Now you can see the flow of water will be there in the 1 inch diameter pipe. Now what you have to do? Come here, directly note down the manometer readings. Left and right limb of the manometer readings. How much you can observe? The 5, left limb also 5, the right limb also. You can see that is 5. So H1 plus H2. So H1 will be 5. So you can take serial number 1. H1 5 millimeters. So H2 also 5. So once after note down the manometer readings, what you have to do? Come here. So close this measuring tank valve, regulatory valve. Then you can observe, you can note down the rise of water level for a known centimeter rise. Example, for 10 centimeter rise I am going to take. From 10 to I am going to observe. Yes. Yes. So 12 seconds. The time taken will be so for 10 centimeter rise. So it's the time taken. So it is a 12 seconds for 10 centimeter rise. Now you can go for the calculation part. So what you need to do? You have to calculate the pressure head in terms of meters. So here H1 plus H2 into 12.6, it derivative, it will mercury head will be converted to the water head. So that's what we have to do. So H1 it will be recorded, there is a manometer readings in terms of millimeters. So that has to be converted to meters. So 5 into 10 power minus 3 plus 5 into 10 power minus 3 it was millimeters has to be converted to meters, multiplied by 12.6. So what is the value H you will going to get? So just do the calculation. So 0.126 meters will be the head. Then rise of water will be 10 centimeters. So again you have to convert it to meters. It will be 0.1. Then time taken will be 12 seconds. So you need to calculate the actual discharge. So Q actual. So how much you are going to get? That is Q actual. So equal to AR divided by T. So what is the area of the measuring tank? So area of the measuring tank, it will be so 0.3 into 0.3 0.09 square meters will be the area of measuring tank into rise of water level, that is how much? 10 centimeter. So I will convert it to meters, it will be 0.1 meters. So divided by time taken 12 seconds. So how much you are going to get the discharge? So 0.09
into 0.1 divided by 12. So 7.5 into 10 power minus 4 meter cube per second. Now you can calculate the velocity of flow. So for calculating velocity of flow, we need actual discharge and area of that pipe. So area of the pipe will be, so diameter of pipe, first we need to note down, that is already we have taken. Diameter, it will be, so 2.54 centimeter. 2.54 centimeters. Now you can calculate area. Area will be equal to pi into, so 0.025 54 square divided by 4. That will be equal to, how much you are going to get, you can calculate. So 5.067 into 10 power minus 4 square meters, that is area of the pipe. Now velocity, so we will going to calculate how much we got. 7.5 into 10 power minus 4 is the Q actual divided by, so area of the pipe 5.067 into 10 power minus 4. So how much you will going to get, just calculate 7.5 into 10 power minus 4. So 1.48 meters per second is the velocity. So after calculating velocity, you need to calculate friction factor. So friction factor formula we know, right? So F will be equal to 2GHD divided by 4LV square. Now 2 into G value 9.81 into head value 0. How much you got? You can see 0.126. You can write in the tabular column also 0.126. Then Q actual how much we calculated, so that is a 7.5 into 10 power minus 4. Then here you can substitute H value 0.126, so into diameter of the pipe, how much, 2.54 centimeters. In terms of meters, if you represent 2.4 in terms of meters, divided by 4 into length of the pipe 1.5 meters into velocity. Here we calculated how much, 1.48 square, 1.48 whole square. Now how much the friction factor you are going to get, you just do the calculation. 9.81 multiplied by 0.26 into 254, so divided by 4 into 0.5 into 1.48 square. Yes. So the friction factor will be, so 4.77 into 10 power minus 3. So that will be 0.0047. This is the Darcy's friction factor. Now this is for that galvanized iron 1 inch diameter pipe. Same procedure can be repeated for the other two pipelines if you want. Okay, that's it. Thank you.